so we are going to continue the second part of the operating system. So first part was the process management. So we spent a lot of time to understand. Of course, that's true. So operating system, the computer consists of a bunch of processes, and then depending on how to manage how to organize such a process, it determines the performance of your operating system. The second part is the memory management. So as we have seen before, and we discussed a lot, the modern computer architecture consists of the CPU, and we have the hard disk drive, storage, and also we have in between memory. Okay, they are connected through the bus. Okay, and we have the peripheral and other input and output devices. So for CPU to access the data, you use mostly the instruction and the additional data. So it cannot access directly to the hard disk drive. Instead, it can retrieve fetch the data from the memory. So, however, unfortunately, the memory nowadays, the price of the memory is getting cheaper. So nowadays you can see some memory-based hard disk drive, okay, SSD. So if you are using the cell phone, most of the students are using cell phone. They are not. The hard disk drive is based on the memory structure, but it's still limited. Comparing to the hard disk drive, it's much more expensive. So we need to still keep such a memory as well as a hard disk drive. So in this the chapter, I think the next 2 or 3 chapters, we will talk about how to manage the memory for the better performance of the operating system. Okay, the first topic is the main memory. Okay, so everybody understand what is the main purpose of the main memory. So it can be used for the cache area. So that is the main part. The problem is limited comparing to the hard disk drive. So we have the limited size of the memory, and most of the people complain my computer is slow, right? One of the main reasons why computer is getting slow is you have more and more processes running at the same time. So check the number of processes running on your laptop, or the computer, or the cell phone. It's huge, okay? So that's true. As time goes on, the number of processes will be increased, which means, what is a process? Process is the program in memory. Okay, that is a process. So which means the more process you have, the more space of the memory will be needed. So, however, if you do not terminate such a process, sometimes the process will be running as a service or a background. So sometimes you may not recognize such a processes. So you do not have enough memory. That means your operating system, your computer will be slower. So that is the problem of the memory management, which means we are going to maximize the usage of the memory by changing the space, or by exchanging the process, or the paging, and so on. So we will see such a thing. Okay? So this is the typical the ways of the process to execute the instruction. So we have the program here. If you execute the program, the instruction will be loaded into the memory. That is what. By the way, what is the memory structure? Memory is what? It's very simple comparing to hard disk drive or the CPU. Memory is a very simple structure. It's what? It's an array of bytes. That's it. It's a series of byte data. Okay. Then each byte, each data will be addressed. So as long as you know the address, you can access the data in the memory. It's just nothing but the array of the byte. that's it. That is your memory. Then we can load the program, the set of instructions to the memory that will be occupied, but we don't know where it goes. Is it beginning, or sometimes it's the end, or sometimes it can be separated. Okay? That is an issue of how to manage the memory. So anyway, this will be loaded. Then CPU, we need to access instruction. For example, the move AX, like the BI, like that. The data in the memory in BI will be accessed then through the address bus. Then we return such a data to the CPU register. Okay, so first fetch the instruction, understand the process the instruction, then the decode. But it's a decode means change this one in the binary format. Each one has, for example, move is 1, 0, 0, 1, 1, and something like that. So you can convert this one, the assembly code, the instruction code into the binary code, is decode, and fetch the data, okay, operand, and finally execute the instruction. Okay, then the result will be eventually saved to the memory. So you can move the memory from AX, something like that. Okay? So that is a typical instruction execution cycle. Then, to each, one of the important tasks of the operating system regarding to the process is how many processes are running at the same time. It's a many. It's not like the operating system like the MS-DOS. Those can manage only one program at the same time. Okay? To execute another program, you need to swap. You need to bring the process down to the terminated and the load another program. However, nowadays we can run the multiple process at the same time, which means because the memory structure is nothing but the array of bytes. Okay, there's no boundary. There's no word. There is no like the classroom or the room or whatever. It's just the array of the bytes. So if somebody other process or the even CPU has something malfunction to access the data, for example, the address is supposed to be the 1000, the 10, but unfortunately it accessed the 10, so the data in the 10 will be returned. That may cause the problem. Okay, logically doesn't make sense. So we need to protect each process first. So for example, the process, the one is from the 256K through the 300, something like that, and next one is this, next one this. How can we do that? We are going to use the two register information that can set up the base address. It's a starting address. For this process in the register, there is a base register. Base register has the starting point, starting address. And limit is the size of the process. Okay? Before we fetch the data from the memory, it will check whether address, decoded address is in between base and base plus limit. Whether this address in between. Otherwise, we will return the error. That is interrupt error. Okay, interrupt this process. There might be malfunction, something like that. So we can use the two register information. One is the base and limit to protect each process. That is the base and the limit to register.
So how do we calculate the size of the process?
Size of the process, it will be, as a default, it will be determined by the compiler. Compiler assign the process, like the default size is the 40, for example, 64K, but depending on the operating system, it will be increased. Okay, if you need it. So that information will be stored at the register information. Whenever there is a context switch, that information still keep until terminated. Okay.
So it can vary or it can be fixed.
It can be. It depends on the CPU and operating system. So this is a slide that shows the logical. It's very simple. So when CPU access the data from the address, it will check whether, for example, move AX BI. So whether the address, first you need to calculate the address that is the, for example, 1030, like that, whether this address in between, this one. If yes, we can access, otherwise it will call the interrupt. It's a fatal error. That's frequently happen, really. Okay? That is the reason sometimes your program, okay? That's kind of the bug in your program. Okay? Because the memory itself is not the guaranteed for each processor. One of the main job of the memory management, process management is how to protect each process in the memory. Think about if the other process update the data in the other process, it will be the other process will be, we cannot believe the consistency of the process. So how can we know such an address? Because as we have seen before, this process, this data structure, this instruction, we don't know where it goes. Sometimes it can be here, sometimes it can be here, which means if this one has the data address like the 100, this is a 0 to 64K, it's a 100. If this one allocate to the beginning, it's a 100, correct? However, if this one is allocated to the 1000 at the beginning as a base, it will be different. So there are process to bind such an address that is called the address binding. Okay, the means when you compile the program, for example, source code is integer I. Integer I means it's the symbolic address. It's just a symbol. It's a high level. So that's just the integer I. However, when you compile it, it will be 100. So move 100, something like the AX to 100. However, this one is not final address. Final address will be bounded based on the base. It's a 1000 base plus this relative address. So the compiled code, that one has usually the kind of offset address. Offset means what is the distance from the beginning of process to that one. Okay. So that is the offset address 14 bytes from the beginning of the module, but it will be when the process link or the loaded, that will be the absolute address. So this one shows the I already explained during the compile time. So and during the load time and execution time, it will be finalized, that address. So this slide shows the how different steps to process such a. So from the source program, okay, so we can compile the source program into the object file. So it will be object module. It has the kind of offset. So during the link and the loader, so it can be the link. The difference between link and load means, so this object module can be executed at the alone. However, most of the program in your C program or the Java program, you import other module, compiled module, other object module, or library. For example, include stdio, and header file, like that, which means you are going to use the existing object file. Or in Java, you import such an object file. At that time, you can link with other library. It's a linking. So combine the object file with your own. Then load means when you load this file to this image to the memory, it will be loaded. So this, for example, standard I/O object module will be loaded and will be used. Or if that shared library is already loaded, then we will share that library. Okay, that is the link and the loader. So during the link and loader, it will be finalized. So absolute address. Okay. There are two types of such a library. Okay. Mostly that is a system library. However, sometimes if you are developing the huge project, so each project may have such a shared library. It's a shareable library, but there are two types. One is the static, and another one is a shared library. Static library, when you design the static library, during the linking and the load process, it will object share the library will be copied and added to the object file. It will not be shareable with other processes, so it will occupy some memory. On the other hand, the shared library, it will occupy only one time. Then it can be shareable. It will be shared by other process also. So you can maximize the utilization of the memory. So mostly it's a shared library is recommended. However, sometimes the shared library may cause the problem at the time. So we can use a static library. It depends on how to compile. During the compiling time of your programming code, programming, you can set the different option for the shared library or static library. If you want if you encounter something problem to use the shared library, at that time you can think about the static library also. So this one is the different types of the address for the memory. We already see from the symbolic address. And logical address is offset, how much far from the beginning of the process. Then finally it will be the absolute address by considering the base register, base address. Sometimes it will take a time to convert such a logical address to the absolute address. So why don't we manage, if that is a frequently happen, why don't we manage some comparison table at the logical or the virtual address and physical address. So that is called the memory management unit instead of calculation. So you need to the offset plus base always to find the address. So it will take a time whenever you need to find the absolute address. Why don't we have something comparison table? Instead of the calculation, we can just access the find the logical address 100. This is the 74100 address. Then go to this address from the memory. So this kind of comparison table is called the memory management unit. Where is it located? Should be in the memory. If that one exists in the hard disk drive, it will be slower, right? So it should be fast to access such a memory management unit, and also it will be appointed to the relocation register. Yes.
What is 100? 100 is the data or the address?
Where's 100?
No, here is the table.
Your table?
No, you wrote on the board. You wrote on the board.
Oh, this is the offset logical address from your source code. So the instruction code. But this is 100, we don't know where it goes. So we need to 100 plus a base the address, right? Always you need to add plus. It's a calculation. It takes some time. It requires one cycle of the CPU. Instead, why don't we make the comparison table? So 100 is always 7,400, 7,400, something like that. Okay? So we don't have to calculate the absolute address. Instead, access this one and find the data.
But how do you get the physical address?
Physical address is this one. So
How do you get
pre-calculate and manage this. We don't have to add the calculate every time. Okay? So this is frequently accessed such an address. We can manage such a table. So that is called the memory management unit.
And it's operating system who does the pre-calculation?
Yes. But that should be located in the memory. So there exists another register to point the address of the memory management unit. That is a location register. Okay. So for example, if the logical address is 500, so it's a physical address 20,000. So also you can manage such a logical versus the physical address for the many processes. It doesn't matter, right? And also you can manage the different the memory management. You can manage the many MMU, the table, okay, in case you have the many memories. Also sometimes some of the routine or some of the function, some of the part of the memory is not always loaded in the memory. So it will be loaded whenever it is needed. At that time, we can use such a relocation register. Okay, then that. So we can calculate the physical address, final address by adding the logical address. So it's the same idea. So still same idea. So we have in the code, we have the relative address. It's offset. Then we have the base address, is starting of the memory and starting of the process. So always we need to add the starting base address plus offset relative address. To speed up, we can manage the memory management unit. That is the logical address versus the physical address. Such a the routine part or the library part, we don't have to load the beginning of the process. Instead, we can dynamically load whenever it is needed. Then we can increase the utilization, the memory utilization. Okay. Also, there is just a dynamic. The loading and linking, the difference between the linking and loading means linking is in your process, you need to have another module. Okay? So if you need it, for example, standard I/O module. So that is called the link. So static link means when you compile it, you can add such an existing module to your object module. On the other hand, loading means when you execute the process, when you execute your object file, so at that time, some other module will be loaded. That is called that is dynamic loading. But dynamic linking means even you are not going to link, okay, during the compilation time. So when it is needed, then at that time you are going to link with the other shared library. So that is the static linking, the dynamic linking. On the other hand, static linking means during the compiling time, it can be linked. So size of the process will be much larger in static linking. Okay. One time, when I upgrade the database server to the 32-bit processor to the 64-bit, nobody solved the problem. It's just error every time. Okay, so even the vendor from the it was called the DEC Unix. It's from Distal. It's HP. Right now it's HP, but HP gave up the processor. But the HP actually produced very nice first time the 64-bit processor. But nowadays they give up to produce the 64-bit. But they couldn't solve the problem. Once we upgrade to the 64 process, so they said we can still use the same library, same thing, everything, but it can be solved when we compile with the set option. So there's no difference. The problem is the size of the process is so very huge. So we need more and more the memory size. So we, at the time, the HP actually provide the free, the memory, the maximum, the memory size. So finally, it was upgraded to the new operating system. Then we can use such a dynamic linking shared library. That is called the shared library and static linking and dynamic linking.
No, but can you quickly go to dynamic linking again? Because
Dynamic linking means first the linking and the loading. Loading is when you execute the program, it will be loaded. So at that time, if you add the object module, that is the dynamic. You can dynamically load it whenever needed. Okay. Then linking means when you need. Okay. So link is the combine the object module with other object modules. So dynamic linking, even you do not the link such a other library, whenever it is called, okay, needed, it is linked. If there exists in the library, you don't have to load. Okay, you can just link with other library that is on the memory. Otherwise, if there is no existing library object module in the memory, you can at the time load. That is the dynamic loading. Then you can dynamically link to other object module from your object module. That is the dynamic linking. Sometimes it's called the shared library. So shared library is the same the name as the dynamic linking. Okay. The other operation needed for the memory management is the swapping. Is there anyone who can explain what is the swapping in computer science? Not housewives swap. What is the swapping?
From main memory to
The main memory,
secondary
secondary memory? What is the main memory and what is the secondary memory?
Computer memory and external memory.
External memory?
It's RAM and hard disk.
It was actually the very important question when I learned the computer 20 years ago. But nowadays, not. Why? Because nobody uses the swap nowadays. Yes?
Isn't it when the RAM is full and it's copying part of its content into the hard drive, so you can free some
Yes.
space in RAM?
So long time ago, when we have very limited size of the memory, so for example, 1995, at the time, even I had the very expensive the computer. I thought it's not 95, 1983. That was the first year when I purchased the first personal computer. Hard disk drive? There's no hard disk drive. Okay, only floppy. So it's called the IBM XT. So to boot up system, so memory size is less than 1 megabyte. So I need to use a floppy disk drive. So I can load only operating system or very limited application. Whenever I execute a new process, new program, we need to free up the older memory, which means swap the process, which means to run the program. Running the program, executing the program means what? You need the memory, but it's full of memory. So we need to swap the process, which means terminate the current process, then load on the new process. Load the new process. That is called swap in and out. Okay. What about the nowadays, the modern computer? Can you see the swap operation? No, we cannot do the swap if we still use the swap operation. Nobody buys such a computer because swap require what? The I/O, input and output operation. Input and output operation is the most expensive operation. Much more expensive than the I/O in memory, I/O in other peripheral devices. So such a backup. So idea is simple. In case the memory is full, okay, we can flush out all the process, then bring the new process. Problem, it requires a lot resource. So nowadays we do not use such the swap operation. However, very limitedly we still use the embedded operating system or small the operating system. They still use the limited swap operation. But general computer, general operating system, they give up to use the swap process. However, you can still see swap space when you set up the Linux system. That doesn't mean they use the swap operation for that space. Instead, anyone who set up the manually the Linux system, so you need to specify the swap space, right?
Yeah.
It can be used for what? It's a virtual memory. So nowadays we call the virtual memory space as the swap space. We will see the next week. Okay, what is the virtual memory? So this slide shows how long it takes for the swap operation. So this is just a simple math, so you can easily understand. So key point is it takes a long time. Okay? So you can compute how much expensive to perform the swap operation. So for for a given process and the transfer rate, then you can calculate the time. Okay. So because of such expensive, most of the modern operating system, they give up the swap operation. What about the mobile system? Do you think the mobile system, the cell phone, use the swap operation? No, actually not. Okay. Instead, it terminates the process and load another application. Okay. Basically, the iOS and Android use the same idea because it has anyway the limited computer resource, the memory size, so they do not keep the current process. It's like the multiple program. Instead, they try to make the current process sleep, then instead bring the other process. Also, another reason is the power. If you still keep the current process as a background, it will consume the power. So to save such a power, they try to make them sleep or to terminate the other application program. But still, you can keep, if you want to keep the certain process as a background, you can set up as the service or the background process. But the more the background process you have, that is the problem of the consuming the battery. So you need to keep your mind if you develop such a mobile application. So first we are going to see how to allocate the memory space to the process. So ideally, if we can have the continuous memory space, that will be easier. Which means this is the memory 0 to 1 megabyte. So address is a lower address, it's a higher address. So if we can find certain amount of continuous part of the memory, we can allocate the process 1, then process 2, process 3. Okay? But if we do not have the space, at that time you can swap out, then bring another process, swap in. So for that contiguous the allocation, first we need to check so as we discussed before, so we need to check whether that is less than the limit register or the location register or base address that fit to the physical address. Okay. Then there are different approaches to allocate the process to the memory. Okay. So for example, this one shows such allocation, contiguous allocation. currently processor 5, 8, and 2 are running. So there are 3 processes. And then, so if we need to load another process 9, so we need to swap out one of them and allocate the memory space for the process 9, process 10, and something like that. At that time, depending on the how to allocate, there are different approach. First one is the first fit, and second is the best fit. Third one is the worst fit. We will see each of them quickly. So this is the current memory allocation. For example, it's a 0 to 3000. The memory 3K memory size. We have this is the operating system part. So the other from 400 to the 3000 is the user space. So there's the H means is whole. It's a free space. It's a free space and the free space and the free space. There are 2 processes currently, process 3 and process 4. What if P1 is executed? At that time, the first fit assigned the lowest address, the whole, the free space, which means in this case the 400, the whole one. So whole one is allocated to the P1. The P1 is allocated to the whole one. So it will be allocated to the first whole. First, the lowest address whole. That is the first fit. Okay? The best fit means when you allocate this one, if you use this H1, it's a 300. So this will be 700. It's a 300 for P1. This part will be 300. The whole size, the free size is the chunk is a 300. Okay. Next time, if we have the 400, the process, 400 size process, we cannot allocate. We cannot use this part. Even though total free space is bigger than this, we cannot use this one. So to maximize such a utilization, why don't we allocate the free space that create the leftover, which means if we allocate this one, 300 leftover. If we allocate this one, it's also 300 leftover. But if we allocate this one, it's 100 leftover. So this one is the best fit. Okay, so that is the best fit. And third one is the worst fit. Worst fit means the opposite of the best fit. Why don't we allocate the biggest size of the leftover? This one and this one is the same, so we can select either of them. However, can we say the worst fit is the worst algorithm? We cannot say the worst fit is the worst algorithm. Worst means it's the biggest leftover chunk. Okay? For example, if we have the 300, 400, so still bigger size. We cannot use, never chance to use the 100 size. If most of the process, their size is bigger than 100. This one is never ever used. So we cannot say the worst fit is the worst one, but there are different approaches. Yes.
But you said before that a process can be in 2 or 3 different areas, right?
That is this one is old fashioned.
Okay.
Contiguous allocation. But right now, the general computer does not use this approach. We will see such a different, how can it? So to maximize this one, why don't we separate, split, and allocate it? So that is the non-contiguous approach. We will see later. So this one is old-fashioned. It's a contiguous allocation. So there are different ways. Okay. This one is called fragmentation. If we allocate this one, sometimes small chunk of leftover never been used. Okay, this problem is called the fragmentation problem. We have actually encountered every day, every time such a fragmentation problem, like the hard disk drive. Okay, I don't think the Windows 7 and 8 the explicitly learn the such a defragmentation, but when we use the window XP, so we learn the from time to time learn the defragmentation. Have you ever used defragmentation? What is that? It takes a long time. Then it moves the file, not the memory. It's on the hard disk drive. You can see the map of the allocation file on your hard disk drive. You can see it's scattered everywhere. So combine the piece of, it's definitely, even though we can separate one file into the several pieces, which one is better? One chunk of contiguous file or separate? Definitely this one is faster. Why? Because you need to link, which means you need only one I/O, two I/O to access this one. But if they are separate, 1, 2, 3, 4, 5, 6, sometimes to access this one, you need to check, and finally access. So how can we address that one? So we can defrag. It's the same thing. So we got the same problem in the memory management fragmentation issue. There are two types of the fragmentation. One is such a external fragment. External fragment is relatively bigger, but still we cannot allocate the full memory, okay, a full process for the chunk. That is called external fragmentation. And also there exists the internal fragmentation. Internal fragmentation means that fit to the something, the memory, the process, and the memory and input and output, they cannot handle 551 bytes. It's usually certain the multiplication times of a certain number, that is usually 2 to the power of 2. So for example, the I/O operating system has the I/O unit as a 512 byte, which means 512 bytes is a minimum size. The operating system cannot read bit by bit, right? It has certain the unit. Okay, the memory is a byte or the word based. So there are some leftover, like the 1 byte, 2 byte, small size of the leftover. That is called internal fragmentation. So there exists the external fragmentation and internal fragmentation. So which means we cannot get the best utilization. So we need to address such a problem.
So
Yes.
that memory it doesn't utilize it. If it is left over, you don't.
Yes, we cannot use that one. For example, this approach is a contiguous approach. So even though we have this one is an example of the fragmentation. So even though we have the total 1,600 byte, the free space on the memory, what if we have the 700 byte size of processor? It cannot fit any of these. Okay? In contiguous. However, this kind of fragmentation will be issue problem in the non-continuous later. So we will see such a problem.
How did you differentiate between external and internal?
External fragmentation is like this one, okay? Chunk by chunk. Internal is you cannot avoid such a thing because of the unit of I. So for example, 551 bytes need for the memory, but it will be the minimum unit is for example 8 bytes. Okay, which means you need 112 bytes power at the times of 8. Okay, should be multiplication. The multiply by the 8, so it's a 512 bytes. So 1 byte will be never used. So fragmentation. Okay, so that is called internal fragmentation. So how can we address the problem of the external fragmentation? Instead of allocating the contiguous, we can non-contiguous the allocation. That we can address the problem. So we will see such an approach later. But anyway, in case of the fragmentation, we can compact such a fragmentation as we just discussed. We can use the free or the space. Then load the memory, load the process again. That is the same problem in the database management system. So one of the main reason why I moved the United States, so 14 years ago already. 14 years ago, I moved to the United States in 2002, right after the 9/11. So, because I watched the 9/11 at my home. So at that time, my wife and me discussed a lot for the moving to United States because most of my job happened at night. Okay? Also, for example, one of the main job of the database administrator is, this is called reorg, which means reorganization. Just like the fragmentation in the memory, in database system, when you insert the data and delete the data, insert the data, update the data, table will be internally fragmented. Okay? So it will take a longer time. As time goes on, so to access the data, sometimes you need to access this one. It takes a longer time. It's getting slower. Okay? So this is called the fragmentation or the chaining. This is called the chaining of the data, chaining issue. How can we address the problem? It's a simple. Back up the data, delete, recreate, and load the data. So it will be simple if you have a very small size of the database. The problem is when you have the 1 terabyte, 1 petabyte size data, it's several hours, sometimes several days. Can you do such a job during the daytime? No, you cannot do that. Usually during the nighttime or the holiday. So most of the time, so I should. Then there's nothing to do. Just wait until upload all the data. So it's a tedious job. And so also, if something happened during daytime, so I can fix the problem. But what if something happened during the nighttime? So operator usually call me. They do not have any authorization to fix the problem. Just inform to the employee. So I was the last one. So my manager never got such a phone call. So I should take care of such a problem. So probably 5 days a week, I should spend the whole night at my office. So that is one of the reasons why I decided to move to the United States. That is the same issue in the memory, the fragmentation. So how can we address the problem? We can compact. How can we compact? It's so simple. So free up all the memory and load it again. Okay? But still it needs a lot of I/O, so that is not a good solution. So we will see another solution to address such a problem. Also, in the before we talk about that is called the paging. Okay, so actually nowadays most of the modern operating system will adapt such a paging operation to manage the memory. So we will see such a paging later. Before that, the segmentation. Segmentation means, as we have discussed before, so we can use the dynamic linking to execute the program, which means we do not load the entire library. Instead, we can load whenever the routine is needed to the memory. Then at the time, if this library and this main object is working together, why don't we combine? Okay, why don't we consider logically they are one chunk of the object file? Then allocate to the same area, same part of the memory. So that is the idea of the segmentation for better performance. So segmentation means it's kind of logically, not physically combined, but logically we can consider some group of the module It can be object file, or the library or function. So we can consider such a group of the module as a segmentation. It's a high level. So logic is a high level, the unit of the logical level of the unit of the module. Okay. Like this one. So we can make them group. Okay. Then if they are working together, 1 and 4, so we can allocate them next to each other for better performance. How can we manage such a segment? It's the same idea as the base register and limit register. So we can have the register that keep the starting address of the segmentation and the size of the segment. Then in between, that is authorized, then we can access the data in the memory. That is called the SDB.